So the notes for today are 13.4a. We're moving on from solving absolute value equations, which is what we've practiced the previous 2 days. And today we're going to be solving absolute value inequalities. So it's important to remember that an inequality means there's going to be a less than, a greater than, a less than or equal to, or a greater than or equal to symbol, but these are still going to have absolute value bars in them. We've solved absolute value equations, we've solved inequalities, but we've never solved anything that has both of them in it at the same time. So you're going to have to kind of prepare mentally for the fact that these are going to have different rules in them than the other types of equations have had. This one says, how is solving absolute value inequalities different than solving absolute value equations? So remember, when we solved absolute value equations the past couple of days, we were splitting them off, making two, having one be positive and one be negative, and some of that will be true today, but there's also some differences in what we practiced today. So all right, so example number one kind of gets you thinking about the new stuff that we're working on in this section. It says, consider the difference between the two absolute value inequalities shown below. So consider the difference between the two absolute value inequalities shown below. So we're going to look at an example A, and then we're going to look at a slightly different example B. Now they're going to be really close to one another, so you have to pay extra close attention to what you're about to write down because you want to make sure that it looks different. For A, I want you to write the absolute value of x is less than 2. And then for B, you're going to write almost the same thing, but you're going to write the absolute value of x is greater than 2. So the notes for today are going to start off with a discussion about how these two things are similar and how they're different to one another. They have a lot in common when you look at them, but in terms of their answers are almost exactly opposite. And so you're going to want to keep that in mind. So question A says the absolute value of x is less than 2. A couple of things just to build some background with this. So remember that absolute value means the distance that the number is away from 0. So if the absolute value of x is less than 2, that means that the distance that the number is away from 0 is less than 2. It can only be up to 2 or just less than 2 above 0, but it can also be just less than -2 down from 0. So whenever you see this symbol, you're going to think of either the word inside or the word within. They're kind of similar in this case. It means that the number has to be inside or within 2 away from 0. And so we could help ourselves understand that a little bit better by drawing a graph. So if I put 0 in the middle, and if I had 2 and -2 be here and here, if the absolute value of x, or if the distance the number is away from 0 has to be less than 2, that means that it can be 0, it could be 1, it could be 1.5, it could be -1.5, it could be -1.9. Basically, it could be anything within 2 up from 0 and 2 down from 0. So if I was going to graph this as an inequality, I would say that these would be where all of my answers were located. So the answers would be all of the numbers that are in between +2 and -2. And if I was going to write that answer out as a question or as a solution, I would say that the numbers that are answers to this question are the numbers that are in between -2 and +2. And I would choose to write it like this because it's an and inequality. And so that's another thing that you want to make sure that you write down on your notes today. If it's a less than symbol, if it has to be within a certain amount from 0, it's always going to be an and inequality for your answer. And so we have kind of a cutesy way that we recommend you practicing that. If it's a less than symbol, less than, so that's a way to remember how it works. So if you can remember that if it's a less than, it's going to be less than, and again, this is kind of just a funny play on words, then that's one way that you can remember the question. So the other one is different because the other one says x has to be greater than 2. The absolute value of x, rather, has to be greater than 2. So this means that x has to be at least 2 away from 0. When you think about greater than problems, it means that the distance the number is away from 0 has to be bigger than 2. So you can think about this as being an at least that doesn't look like the letter A. Let me fix that for you. It's an at least question, or you can think about it as it being an outside question. So the distance the number is away from 0 doesn't have to be within something. It has to be bigger than or outside of something. And so if I was going to graph this same thing here on this number line and understand what this question means, I would still set up my +2 and my -2, but this one says that the distance of x has to be bigger than or equal to 2. So it means that it's not going to be inside of here. It has to be more than 2 away from 0. It has to be 3 away or 4 away or 5 away or 6 away. Or in this direction, if it were at -3, -4, -5, then it would be more than 2 away from 0. So just looking at the graphs, you can see how these are different. This is an inside graph. This is a less than graph. It's an and graph because it's what's on the inside. When you shade on the inside, the x is on the inside. This graph is the opposite. It's not shaded on the inside. This is an at least graph or an outside graph. It's great. The equation right here, the inequality right here is greater than. And so when I write my answer to this question, it's different. X either has to be less than or equal to -2, or x would have to be greater than or equal to +2 for this to be the case. And so, again, math teachers love their cutesy little things, but we have a way for you to remember this. If you see a greater than symbol right here, the cutesy thing to remember is great or than. And so if you're remembering that this one is the and that this one is the or, it's also true, and you can remember it this way, that anytime you see an and, a less than symbol, it'll be an and problem. And anytime you see a greater than symbol, it'll be an or problem. And that's even going to be true when the question has other numbers in it. And so that's part of what we're going to practice today, is we're going to practice solving these when they have other numbers inside of them. Before you move on to the next question, it's really helpful to let your eyes go back and forth. This one has an x, this one has an x. This one has bars, this one has bars. This one has a less than symbol, this one has a greater than symbol, and then they both have 2's. So the only thing that's different about this one and this one that tips you off to what the answer is going to be and what it's going to look like is when you look at the symbol or the direction of the inequality symbol, and that helps you decide which one's which. So today's notes are not going to be long. We're just going to do one example of each kind of problem. But the biggest thing that you have to remember is that you're looking at the direction of the symbol of the inequality, and that's what I really want you to focus in on. So we're going to do example 2 right here, and then we'll do example 3 on the back. But here's what example 2 says. The directions for example number 2 say they want you to graph and solve. It could also say solve and graph. I guess that would make a little bit more sense, but just at the end of the day, make sure you get both of them done and you'll be fine. So it says graph and solve. And then here's the inequality that you're going to graph and solve. The directions for this one say the absolute value of 4x minus 8 is less than or equal to 4. So it has bars, it has an x, it has an inequality symbol, and it has a number. So I know that this is an absolute value because it has the bars, and it's an inequality because it has an inequality. As soon as you see that this one has a less than symbol, you know that this is going to be an inside or a within inequality, because some number is going to have to cause this to be within or inside of 4 away from 0. And so again, if you want to remember it the other way, you would remember that this is a less than question. And so because it's an and problem, I'm going to set my work up assuming that I know that it's going to be an and question. So the next thing you write down changes if this is facing the other way. So you have to look at this to see what you're going to do next. For this problem, I'm going to write down the 4x minus 8 in the middle. I'm going to drop the bars from it right here, so there's no more inequality bars. There's no more absolute value bars right here on my problem. I'm going to do a less than or equal to 4, so this side stays the same, but then I'm going to come over here to this side, and on this side, I'm going to put a -4. It's always going to be the negative of whatever this number was over here. And I'm going to put what looks like a copy of the absolute, of the inequality. It's actually facing the opposite direction because you have to remember that you read this from inside out. So this is actually a greater than symbol that's just been flipped backwards. So to recap, before you move on to finish solving this, what's on the inside goes here in the middle. This side stays the same, and then this side is the opposite, and then the corresponding inequality symbol that goes right here. Part of the reason why I set the question up to look like this is because I know that it's going to be an and problem. I know that this has to be within 4 from 0. So I know that my answer is going to be colored on the inside. It's not going to look like this one did and be colored on the outside. And then you solve it based on the way that you set it up. These questions in 13.4a require a ton of thinking. You have to really stay on your game when you're solving these. You have to be thinking about them the whole time that you're setting them up and solving them. So to solve this one, I did plus 8, plus 8, plus 8. And then I'm going to do divide by 4, divide by 4, divide by 4. Remember, I'm trying to get the x in the middle all by itself. And so when I write down the answer to this question, 1 is less than or equal to x is less than or equal to 3, I already knew that it was going to be an and question because I knew from the very beginning that this had to be within a certain range. They wanted me to both solve and graph my answer to this question. So if I put the 1 and 3 on a graph, the answer to this question just says that x has to be in between 1 and 3. It's going to be closed circles because they're or equals to when I'm graphing them. And so then I'll shade this stuff that's here in the middle. When you graph an and inequality, you can draw it like this, or you can draw it like this. You have to make sure that the circles are either open or closed, but I just wanted to point out that this graph and this graph mean the same thing. Sometimes you'll just see it raised up a little bit, and other times you'll see it just colored in directly in the middle, but those two things mean the same thing. So the answer to this question is, or would be, all of the numbers that are in between 1 and 3, including 1 and including 3. So you've got numbers in here like 1.5, 2.5, 1.75, a lot of stuff that happens inside of here. And so those are your answers to the question. So absolute value of x, or the absolute value of 4x minus 8 is less than or equal to 4. The answers are all the numbers in between 1 and 3. Before we flip over onto the back of the notes, I want to write down 2 takeaways from this page that I think are important. Remember, your takeaways are 1 to 2 sentences about the page that you think is important or that you think matters. I think that looking back on this page and the different examples, the most important thing is how you decide how to set the question up. So for my takeaways right here, I'm going to write down that if it's a less than symbol or if it's a less than or equal to symbol, so if it's either one of these two, that means that you will have an and answer. So if you see less than, or if you see less than or equal to, that means that it needs to be within a certain amount from 0. So that means it's going to be an and answer. And then alternatively, if you see a greater than, or if you see a greater than or equal to symbol, that means you will have an or answer. So whereas and means that it needs to be within a certain amount, or means that it needs to be outside of that certain amount. And so that's the distinction between them. You have to make sure that your brain stays turned on the whole time that you're doing this, because one false move into thinking that it's this instead of this, and it means that you'll get the question wrong. So if you look at the example that we did right here in the notes, this was your and example. And so the only other thing that we have left to do today, go on ahead and turn over to the back, is we're going to do one example of an or example, and then we'll stop. What you actually need to do to get better at these isn't necessarily just practicing solving them. What you actually need to do to get better at these is you need to practice seeing them mixed up with other kinds of problems and picking whether it's going to be an and problem or whether it's going to be an or problem. And so that's what I want you to have more practice with today. You're going to get a lot of time today to start working on the assignment so that you can dive into, distinguishing between the two. So here's this one. For example number 3, it says solve and graph, and here's the question. The absolute value of 6x plus 9 is greater than 15. The absolute value of 6x plus 9 is greater than 15. If you compare that to this one, it looks almost exactly the same. It has bars, it has an x, it has an inequality sign, and it has a number. So it's super tricky because you might think that this is going to be the same thing, but it's not. This says that 6x plus 9 has to be more than 15 away from 0. The distance that this is away from 0 has to be greater than or equal to 15. That means that it needs to be outside of a certain distance away from 0. And so that's how I know that this is going to be an or graph. Also, great or is a way to remember it, but it's better to think about it in terms of how the numbers work. So If it's an OR graph, you need to set it up and solve it with the two pieces because you know that the graph for your final answer is going to have one part going to the left and one part going to the right. When you do that for this question, you're not going to put the 6x plus 9 in the middle and do the thing with the 15 and the negative 15 like we did on the notes back here on the previous page. We only did this because we knew it was going to be an AND problem. On this example, we know that it's going to be an OR problem. So when I solve it, I'm going to solve it the same way I would solve an OR problem. You're going to drop the bars. You're going to write 6x plus 9, so no bars on this one right now, is greater than 15. What you write down over here is the same thing that you had up here, except you drop the bars around the absolute value. So it says that this can be 15 above 0. And then when you come over here, 6x plus 9, there's two things you have to fix. So the first thing is you have to put the inequality sign in the opposite direction. So it's going to be a less than symbol right here, not a greater than symbol. And then the other thing you do is you have to change the 15 to be negative 15. It's kind of like when we solved absolute values that had equal signs and we had one be positive 15 and we had one be negative 15. The only thing that's also different about this is that you want to see right here that this one changes direction, and so this also flips to the opposite side. So 6x plus 9 has to be above 15 from 0, and then 6x plus 9 has to be below negative 15 from 0, and that would satisfy the conditions of this absolute value inequality. Once you get it set up, you have to rely on your previous math knowledge to get you through solving it. So 6x is less than negative 24. And so my two answers for this question are going to be x has to be less than 1 for this part, or sorry, greater than 1 for this part. And then over here I'm going to get x has to be less than negative 4. And so a lot of students will put separate boxes around the two of these things, but it's tricky because they're not actually separate answers to the question. This is answers to half of it, this is answers to half of it, but when you write your answer to the question, you have to write them together as one. X has to be greater than 1, or x has to be less than negative 4. And so when you write the answer, you want to put the word or in the middle. Some students, when they write this down up here, will automatically write the word or up here so that they remember that they're going to have to write the word or in their answer. And so I think if you wanted to do that, it would be a great idea. This says that x has to be bigger than 1. So I'm going to do a closed circle on 1, and I'm going to shade above 1. So I'm shading all the numbers that are bigger than 1, like 2 and 3 and 4 and 5 and 6 and so on. And then it also says that it also works if x is less than negative 4. And so I'll do a closed circle on negative 4, and then I'll come over here and I'll shade all of the numbers that are less than negative 4. So negative 5, negative 6, negative 7, and all of the numbers that go in that general direction as well. Your entire solving process looked different than it did on the front with this example simply because this was a less than symbol and simply because this was a greater than symbol. And so tonight in the homework, they're going to all be mixed up with one another. And so you're going to have to go through and you're going to have to pick out which ones do you solve using this way and which ones do you solve with the dot, 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 dot arrow, and you solve by putting the number on the other side. You're still making the 4 be negative, just like on this one, you made the 15 be negative when you put it on the other side here. But it's a different solving process, it's a different answer, it's a different graph, and so you want to keep that all in mind. So let's come down to the bottom. That's the only example we're doing on this page, and let's write a takeaway together. When you solve absolute value inequalities, and that's what these are. They're absolute value because they have the bars, and they're inequalities because they have the less than or greater than symbol. So when you solve absolute value inequalities, you will get either an AND answer or an OR answer. And I'm just circling these words because it makes them stand out a little bit more. You don't have to circle them. That's not like a special math thing. When you solve absolute value inequalities, you will get either an AND answer or an OR answer. Oh, and then one other thing that I want you to write down here says these answers are sets of numbers. So these problems do not have or don't have just two solutions. They have many solutions. That second part of the takeaway isn't really something that you saw up on the previous part of the notes up there. It's just really important that you understand that. And so I decided instead of writing it up here, I would just write it in the takeaway. These answers are sets of numbers, so these problems don't have just two solutions, they have many solutions. They have all the numbers that are over here, and they have all the numbers that are over here. And so understanding that will help you if a question asks you to provide a solution to the question. But remember, the big key is this first part. It's all about whether it's an and or an or based on the direction of the inequality symbol.